Okay, let's do some review and step it up a little bit, okay? So the center is this, so we always do the opposite. Squared plus the opposite squared equals the radius squared. That's it. This is the same thing, but this time I messed with you. It says radius, but it should be d equals 14. D is the diameter. The diameter is the whole thing, but I only want the radius, which is half. So that means r equals 7. So now it's x minus 19 squared plus y squared. There's a 0. I'm not going to put minus 0. Equals 49. And that's it. All right, they want the domain and range of each circle. So let's think about it. If I had you graph this, this would be the center 0, 0. And then it would be 12, negative 12, 12, negative 12. So there's my sad little circle. But that means the domain is negative 12. It's less than x, which is less than 12. The range is negative 12 is less than or equal to y, which is less than or equal to 12. In interval notation, I don't have very much space. It's negative 12 to 12. In interval notation, it's negative 12 to 12. Okay? Let's look at the next one. I want you to see the difference between the circle domain versus this one. This one's squared, but this isn't squared. That means this is a U. So if it's a U, the important thing I have to find is my vertex. There's two ways to find the vertex. One way to find the vertex is find your x's, which is like my elbows, and figure out what's in the middle. Okay, so the middle of that would be negative 2. So that would be, let me move this over, the x value of my vertex. The other way to do it is negative b over 2a. Whatever you want to do, I don't care. To get the y, you go negative 2 squared plus 4 times negative 2 minus 32, 4 minus 8 minus 32, negative, did I do that right? I think so. Negative 16, negative 48. So since I know my vertex, now let me zoom out a little bit. I didn't leave very much space. Sorry about that. I can find my domain and range. If it's a U, that means it's all real numbers, negative infinity, positive infinity, because everything to the right, everything to the left. But then it starts here and goes up. That's my y. Y is greater than or equal to negative 48. Bracket, negative 48, positive infinity. I hope this is review for you. Okay. All right, let's see. We got something at negative 4, 7. And everyone is within 5 miles of it. So I don't know if you've ever seen those shows, but they have like makes a circle, right? That means the radius is 5. So I have to go this way 5, this way 5, this way 5, and this way 5. Okay. First thing they want is the equation. That's, to me, not as difficult. Now the difficult part is, let me make the graph a little bit better. They actually probably, I know I'm going to want this. I'm going to want the vertices as well, which means that when you graph negative 4, 7, and there's the center, I'm going to want to know that everything to the right, that's at 1, to the left, negative 9. So that means I have negative 9, sorry, let me make that a little bit higher, negative 9, 7, and 1, 7. And then everything up, 12. So that's negative 4, 12. And everything down from that would be at 2. Now, some of you go, wait, what did she do? Well, you know my little robotic people. It's, in a sense, if you have negative 4, 7, that means you're going plus 5, minus 5. Positive 1, negative 9. But the y stays the same. Then what you're doing is plus 5, minus 5. Plus 5, minus 5. Okay. Whatever way works for you, works for me. All right, we need to prove if this is equal or not. So I'm going to box this out. When I box this out, I get x squared minus 3x minus 28. And I'm going to multiply that by 2. Rainbow bow. 2x squared minus 6x minus 56 equals. Okay, so that side's done. Now I got to do this side. So this is being added, but this is being multiplied. So based on PEMDAS, I box it out first, x squared plus 3x plus 2. And now they're asking me to add it to this. So I'm better if I add vertically. I get 2x squared minus 6x minus 56. Oh, they're exactly the same, so the claim is correct. Write this in as many ways as you can. So one thing I could do is I could take out a 9. That's just the way I see it. Another way I could do it is I could square root this. Another way I see this, when I'm looking at this, I see this as 3. Well, actually, I don't like that one. I could distribute this in there and get 18 minus 9x, and then 2 plus x. That's another way. Now, by the way, if you're going to do this one and distribute, you can't do this one. You can't go like this. Oh, another one I see is 2 minus x, and then 18 plus 9x, because these two are exactly the same. Okay. I could also see the 9 as 3, 2 minus x, 3, 2 plus x. Okay. Those are a couple different ways, and I'm sure there's more, but I just want to show you some of them. Okay. Simplifying this, this is a 2 by 3. So this is review. And I am boxing this out because I think this one's a little bit more difficult. So that's a cubed minus a squared b plus ab squared plus a squared b minus ab squared plus b cubed. Let's see. Oh, those are the same because this is a squared b minus a squared b. That's gone. ab squared minus ab squared. That's gone. Oh. So this is the sum of cubes. Interesting. Okay. I'm going to jump over to this factor one because I feel like it. This reminds me of x squared minus 7x plus 6, which is x minus 1, x minus 6. But it's actually x to the 8th. So the way you get that is if it's x to the 4th. But you know I can keep going, so I could square root, x squared minus 1, x squared plus 1. But I can't square root this, and I am not solving, so leave it. Now, I can square root this one. X minus 1, x plus 1, x squared plus 1, x to the 4th minus 6. So that is my answer. If I wanted to check to make sure my answer was good, I could take this, graph it, take this, graph it, and they should be right on top of each other. The only downside is these two are also equivalent, but it's not fully simplified. Okay. I'm going to zoom in on this one because I think this one's the most difficult. So when I see this one, what makes it confusing is if the s wasn't even there, that'd be easier. And if that was squared, that would be easier. And if it was an x, it would be even easier. So I'm going to simplify it and make it easier for my brain. 3x and x. If I try a 2 here and a 1 here, that's a 1 and a 6. That's not going to give me a 5. So I switch them. 2 and 3 gives me a 5. So now I've got the most simplest form. So now I have to go back. Now I'm simple, I have to go back to fancy. So it's not an x, it's actually an r. And it's r to the 6th, so that would be r cubed. And that's actually, because I erased it, there's an s squared, so that'd be s. And let me move this over a little bit. And that would be an s. And some of you go, I'm not too confident. Okay, if I boxed this out, sorry you can't see that. If I boxed this out and I went 3r cubed s minus 2 and r cubed s minus 1, this times this gives me this. This times this and this times this added gives me this. And this times this gives me that. Okay? All right.